respiration, I start with glucose. Cellular respiration happens at the mitochondria. We get glucose from the food that we eat. Also, it's important to mention that inside of this mitochondria, all of the oxygen is just being pushed right to the middle of this mitochondria. The mitochondria has two membranes, the smooth outside membrane and the wrinkled inner membrane. Oxygen is gathering inside of here, and at the very end of this story, you're going to see why oxygen is in there. So here we go. The first step of cellular respiration is called glycolysis. In glycolysis, it means glucose to split, and that's exactly what we're going to do. We're going to break this glucose in half, and you can see it takes a little bit of energy. 2 ATPs of energy are used to break that glucose, and when it breaks, the breaking releases 4 ATPs of energy. It charges 4 ATPs. So actually, we just gained 2 ATPs right here in glycolysis. When that glucose splits, when it breaks, thank you. When that glucose breaks, 2 of the hydrogens are lost from the molecule, and they're picked up by an H acceptor that's called NAD. NAD picks up an H, and it becomes NADH, and I'll show you what happens with that NADH later. NAD picks up an H, it becomes NADH, and I'll show you what happens with those in the last step of cellular respiration. These pieces are now called pyruvic acid, and they are ready to go into the mitochondria. As those little pyruvic acid pieces go through the first membrane of the mitochondria, they get changed a little bit. There's a little reaction that happens, and we are going to lose a carbon, and we are going to lose a hydrogen from each of those pieces of pyruvic acid, and they are now called acetyl-CoA as they enter the citric cycle. I always have to know what happens with these beads, though. The carbon beads are the easiest to get rid of. We exhale carbon dioxide all the time, so that's just garbage. We get rid of it. The hydrogens are what we are hanging on to. The hydrogens are picked up by NAD, forming NADH, and I put them with my other NADHs right there at the top of the electron transport chain. Now I take my acetyl-CoA and I go through the citric cycle. And this is really happening kind of in this first space of our mitochondria. And in the citric cycle, I'm just going to show you one of these pieces of acetyl-CoA. I break all the remaining bonds. And, like always, I have to know what to do with those pieces. The carbons I exhale as carbon dioxide. 3 of the hydrogens are picked up by NAD, forming NADH, and I'm just putting all my NADHs here. And when I see that last bead sitting there, that reminds me 1 ATP gets charged. Yes! Remember, ATPs are what we are after. We've got 1 ATP charge from breaking apart that acetyl-CoA. And my last H is picked up by a lower energy H acceptor. Can you just see the low energy there? The low energy H acceptor is called FADH, making FADH2. Okay, here we're going to do it again. Oh, just tipped over all my H's. Here we go. Breaking apart our acetyl-CoA in the citric cycle. I break all the bonds, and I have to know what to do with my beads. The carbon I exhale as carbon dioxide. H's, 3 of them are picked up by NAD, forming NADH. When I see that last one there, it reminds me to say I charged 1 ATP, and that last lower energy H is picked up by FADH, forming FADH2. Now I'm ready for the ETC. Remember, this can't happen unless who is waiting inside of my mitochondria?
Oxygen.
Oxygen. Yep, oxygen is waiting there. All right. Yesterday I told you that there's a protein that sits on this membrane, and hydrogens are thick on this side now, and they want to move through that protein. And as they come through, I told you it's like the thing that spins the pennies at the entryway to Walmart. These hydrogens come through that, and as they come through, it gives us the energy, each one, to charge 3 ATPs. I've got 10 of these NADHs, and as those electrons come through there, that would give us 30 ATPs, 10 times 3. And who catches them on the other side here? It's kind of like we think of them falling down the steps. Oxygen catches those hydrogens, forming water molecules, which we can easily exhale. These lower energy H's that are sitting on the FADH2s, they come through those, charging up 2 ATPs as they come. Each one charges 2 ATPs. 2 times 2 is 4. Oxygen catches them on the other side of the membrane. We exhale them as water. And now, let's just recap what's happened here. I gained 2 ATPs in glycolysis. I charged 2 ATPs in the citric cycle. I got 30 and 4 more ATPs in the ETC. And I have taken my original glucose and I have exhaled the whole thing as carbon dioxide and water vapor. I got 38 ATPs from a single glucose molecule.